If you can ask them to just be quiet for just an hour, that would be awesome. Now, we're going to try this again. So, how many of you are feeling nearly perfect? Raise your hand if you're feeling nearly perfect. So, last week you learned about perfect numbers. Who can tell me the first 4 perfect numbers? Raise your hand.
Can't raise my hand.
Tess, can you tell me? Tess M?
6, 28, 496, 8,128.
Unbelievable. And the 5th perfect number starts with 33 million. So it's just insanely low. Now, there's a parent yelling in the background. If that person could just ask the parent not to do that, or maybe you could go to a quiet place, and that would be awesome. So now, here's what I'm going to do. We're going to try to figure out who's making
I need to read it myself because I need to talk to
you. Well, no, that didn't work. I think I found the person. Asher, I think that was you, buddy. So if there's any way you can ask the family to be nice and quiet during the session, that would be just amazing. Awesome. Okay, so I'm going to exit full screen right now. I'm going to go to your file, and we are going to talk about my favorite numbers today, which are nearly perfect numbers. So everybody first, go to page 2 in your packet. So everybody go to page 2 in your packet right now. Now, on page 2, there's a picture of something called Sierpinski's triangle. Now, someone studied Sierpinski with me, and it's very cool. Sierpinski found fractals in Pascal's triangle. Let's see if we can find it together. So I'm going to look for a triangle here. I'm going to make it a little thicker. And let's see if I can maybe make it in red.
Here. So
Let's try. So you guys see that triangle right there? You guys see it? Now,
yep.
What happens if I click on it
I can hear myself
and I make it a little bigger? Does that triangle look the same as the one on top?
Yeah.
And what about this one? What do you guys think about that? Is that the same as the other 3 and the other 9? And what if I keep going? Aren't those the same as the other 3, the other 9, and the other 27? And let's keep going. Aren't those the same as the other 3, the other 9, the other 27, and the other 81? And finally,
What he's talking about, he's just saying.
is this the same as the other 3, the other 9, the other 27, the other 81, and the other 243? Guys, this is what a fractal is. And Sierpinski was the famous mathematician who found it. Now, guess what? Sierpinski is responsible for one other really cool thing. Would you like to know what it is?
Yeah.
Sierpinski found nearly.
What are you doing?
Wait, somebody is speaking at the same time I am. If that's you, please mute yourself. If that's not you, just don't talk, please. If I'm, and when I call on you, then you definitely should talk. So Sierpinski found something called nearly perfect numbers. And Bayram, question.
So I noticed when you were talking, so when we were doing like that triangle thing at the beginning, you said that the other 3, the other 9, the other 27, the other so on and so forth. And I noticed that you're just multiplying numbers by 3.
Well, let's see if you're right. Everybody, let's check out and see if Bayram is right, okay? Do you agree that there's, let's say, one of these triangles in the green? Yes?
Yes.
Multiply that by 3. Are there 3 of these?
Yes.
Yeah. Yes.
Are there 9 of the smaller ones? Yes.
Yeah.
Yeah. Yeah.
Are there 27 of the smaller ones?
Yes.
Yes.
Now, guys, I don't even know if I have time to do all 27, but who knows what 27 times 3 is?
Let me think.
Or just add 27.
81. 81.
81.
And guys,
81.
we keep going. We get to 243 and 729 and 2187. Let's do this together, guys. Ready, go.
Guys, quick tip.
Give me your
As
hands.
soon as I said, wait,
Bayram?
Mr. Kramer.
Bayram, hold on. Everybody give me your hands and close. Say 3,
3.
9,
3. 9.
27,
27.
81,
81.
243,
243.
729,
729.
2,187.
2,187.
That's 3 to what power? Look at your hands. How many?
7. It's 3 to the 7th
Guys,
power.
That's 3 to the
To the
7th
7th
power.
power.
Now, I'm going to write that down. 3 to the 7th equals 2,187. Please raise your hand electronically if you can tell me what is 3 to the 5th power, which would be 3, 9, 27, 81, and something, the next one. I'm going to ask you to say it on 3. 1, 2, 3, go. Come on, 3 to the 5th power.
Oh, 2 to the 5th power?
3 to the 5th power.
It's 243.
Awesome, awesome, awesome. Now, Sierpinski also figured out how to find something called near perfect numbers. And this is what he did. Sierpinski looked at a number like 12. Now, what is special about the number 12 when we were looking for perfect numbers last week? Number 12 was the first number of a particular kind. Who can tell me what kind of number 12 was? Mark?
There was, when you were factoring it, there was a 6 in it.
That is true, but lots of numbers have 6 as a factor, like 6, 12, 18, 24. But what is special about the number 12 that we found last week for the first time? Who can raise their hand electronically? And I'm going to choose Jonah.
That it's abundant.
Oh, is it true, everybody? 10 plus 6, oh my gosh. Guess what? Jonah is right. 12 was the first abundant number. And now, can we take one number away from 16 that is in the proper factors to get to the number 12? If you say yes, please raise your hand electronically. Come on, 16 minus what? Come on, Claire, I want you to
4.
think about this. No, don't say it out loud because then everybody stops thinking. So on 3, 1, 2, 3, go.
4.
Now, the number 12 we now know is called near perfect. And it is the first nearly perfect number. And the number 4 is called, everybody write this down, redundant.
Redundant.
It's redundant because we don't need it if we want to get to 12. Penny, question. Penny, you had your hand up, honey. Go ahead.
Didn't mean to raise my hand.
Okay, David,
Now I can't even lower it.
you'll figure it out. David,
Raise it again.
David, you had
I
your
for-
hand up, buddy.
Oh, I forgot.
Say again.
I forgot.
Do you have a question? All right, Baron, do you have a
forgot it.
question?
Is it okay if I have a comment?
Yes, of course.
Okay, so earlier when we were doing the times 3 thing,
Yes.
I noticed that you said on 3. Come on, everybody. 27 times 3. And then I said, once you counted, I said 81. And then, well, we started thinking, and then I said 81. And then everybody repeated after me saying 81. And that's not cool because, well, first off, you just got it from me. Second of all, you don't know if I'm right. How do you know I'm right? What if I'm wrong?
Well, I think that it's an interesting comment. But what I would do is I would focus only on your own thinking, and everybody else can focus on their own thinking. But I think that you're right that people should think for themselves. But I think that 81 was pretty cool because they saw that 27 3 times was 3 7s is 21 and 3 20s is 60 and 60 and 21 together made 81. Now everybody goes
You're black
to page 3.
What?
There's still somebody
You're black.
talking in the background. I would love it if that person would ask their siblings and parents to please give them a quiet space. It would be so special and very respectful. So let's try that again. Now, everybody go to page 3 and look at how I've written out the first 28 abundant numbers. And I've circled the number 12 and I've written down 4 as the redundant number for 12. Now, why do you think I gave you 28
Everyone keeps freezing.
abundant numbers? Why do you think I gave you 28 abundant numbers? Go ahead, Jack, but you'll have to unmute yourself. Everybody should be unmuted, please.
Was I frozen on there?
Guys, they were all nearly perfect.
Ah, 28
Spring,
is
unmute yourself.
actually a perfect number. That's why I gave you 28. Now, let's do one together. Why don't we all do the number 1? Oh, you know what? Let's do the number 18 together. Everybody do the number 18. We're going to factor 18. Everybody say the second factor pair on 3. And don't yell it, just say it. 1, 2, 3.
No.
2 and
9.
You have to say 2 and 9. Now, since 9 is an odd number, we can't do double half. What other number factors into 9 On 3, 1, 2, 3.
3.
And therefore, the third factor pair is on 3, 1, 2, 3.
3.
3.
3.
No,
And 6.
3 and 6, because 3 times 6 is 18. Now, everybody right now, I want you to notice how you can add up the numbers 9 plus 9 to get 18. Does that make 18 nearly perfect?
No.
No, because you need to exclude only one number, and we have two numbers excluded. So Mark, do you have a different way of getting to 18?
Yeah, so you can add 9 to 1 and 6. That would work.
Everybody look at what Mark just did. He just added 9 plus 6 plus 2 plus 1 to get 18, giving us a redundant number of what?
3. 3.
So 3 is redundant and 18 is nearly perfect, just like you guys. Now go ahead and circle the number 18 and write the number 3. Now the next one we're going to try is 20. Factor 20. Say it out loud. 1 and 20, go.
1 and 10. 2 and 10.
4 and 5.
4 and 5.
Now, what I want you to do now, because this is my best practice, add the proper factors on 3. 1, 2, 3, go.
10 plus 5.
22.
20.
And if you got 22,
22.
I wonder if you added 1 and 4 and 5 and 10, 22. So what I like to do is I like to find the total and then say what number has to be the redundant number to get me back to 20. And therefore 20 is near perfect. Everybody say the redundant number, go.
2.
2.
And now, can anybody please make a conjecture about what the next near perfect number is and what the redundant number will be? Who has an idea based on this pattern, what will be the next near perfect number and the redundancy? I'm going to go with Hayden first and then Gabby. Go Hayden first.
1.
But which number though do you think will be nearly perfect?
24.
Okay, and Gabby, what do you think?
I think 24. I think the number that goes below will be 1 because 4, 3, 2, 1.
It makes a lot of sense. And Jonah, what do you have an idea? Remember, don't answer it. Don't answer it if you calculated it. Answer it only if you see a pattern. Jonah?
Okay. Yeah. I think it's the same thing as the next nearly perfect number is 24, and the redundant number is going to be 1.
Everybody, let's do it. Come on, get your separate piece of paper. Factor 24. It's one of my favorite numbers. I love it. And Mark, this number is also a multiple of 6, which I know you love and I love too.
Mr. Kramer, I calculated it.
Oh yeah, don't say it out loud.
I'm not going to say anything. I'm not going to say
Good.
anything.
Good, and it's interesting, everybody. It's very interesting because I also thought that the redundant number would be 1. And when I did this, and I start to now add these numbers, I put them in order, and then I add them up, and I am very focused. I am very focused on finding my 10s. 2 and 8, 6 and 4, 6 and 2 10s make what, everybody?
36.
And plus 10 more is?
36.
And so Bayram, what's my redundant number?
12.
Now, guys, isn't it interesting? 24 is the next near perfect number, but 1 is not the redundant number. It, in fact, is 12. So even though everybody, including Mr. Kramer, thought it was going to be a 1, it is a 12. Jack, do you have a question? No? Okay, I thought I saw somebody raise their hand. Okay, now I want everybody to choose their own. In fact, you could do 10 numbers. I want everybody to choose their own number in the first 28. If the number is not redundant, I want you to put an X. So let's say the number is, I don't know, 47, which is not nearly perfect. You're going to go like this and cross it out, and there's no redundant number. But if it's a nearly perfect number, you circle it and write the redundancy below it. And then anybody, we can try your number. And so everybody start right now. You can either go in order, you can choose higher numbers from this list, but everybody has to work really hard. And if you have a question, if you get stuck, you also have to ask a good question. Only the best mathematicians ask good questions. Oh, by the way, the family was talking before, they stopped, and I really appreciate that. That is so awesome. And if you run out of numbers to test, I've got way more for you.
Wait, are you writing down all the numbers on this list?
You are gonna check to see if they are near perfect. And you're gonna find.
Okay, I don't have the pages right now, so I'm just gonna write it in my math notebook.
Yeah, and you have it in front of you.
Yeah, of course, I'm writing it down right now.
And Gabby, question, honey.
I'm trying to practice doing it for 66.
Yes.
And I got a little stuck after 2 times 33. I did 2 times 2 and 33, but then I couldn't figure out what comes next.
Now,
I know
Gabby,
11.
Gabby, what number do you think goes evenly into 33? What
11.
times what? Say again?
11 times 3.
So Gabby, your next number is 3. 3 goes into 66. How many times?
Oh, God.
And Gabby, watch this. 3 goes into 6 2 times.
Oh,
And 3 goes
22.
into 6 2 times. So the answer is 22. And then what's double and a half, Gabby?
6 and 11.
You got it, girl. So guys, I hope you all learn from Gabby to ask good questions.
And is
You have a good question.
Is that the last one, though, to you factor?
Yep, because 11 is a prime. And Bayram, you had a question?
I have a comment that I realized on something that I noticed.
Yes. As long as you don't give away the redundancies or near perfect numbers of other numbers, because I want other people to try them.
Okay, so I was factoring 30, and I noticed that one of the factors is 2 times 15, correct?
Yes, sir.
And then, so what I did was I added 1 plus 5 in 15, and then that equaled my next number in the first column.
Oh.
So add.
Interesting. What I would do is I would look at 15, Bayram, and say 3 times 5. And so 3 is my next factor pair, and 3 times 10 is 30. And then you could do your double half.
Okay, but I just noticed that, and that's another way to find the
It is very nice. Now, Penny, you had a good question. Go for it. Say again, hon?
Figured it out.
Oh, you figured it out?
No, I didn't.
Yeah, so tell me, which one are you working on?
Doing and I got to 2 and 15.
Oh, you're doing 50?
30.
30. Okay, so do you remember when we just did it a few seconds ago? We did 1 and 30, 2 and 15. Now, Penny, what two numbers multiply to make 15? Penny, are you looking at my screen?
Yeah.
Okay, so what two numbers multiply to make 15?
5 and 3.
And so therefore you take the smaller of those numbers, which is 3, and you say 3 goes into 30. How many times? Because 3 times what is 30? Go ahead.
10.
Nice. And then you double 3 and take half of 10. Go for it.
3, 6, 7, 5.
Mr.
You want to say 6 and 5?
Said 5.
And then you are done. Does that make sense to you, honey? Does that make sense to you?
Yeah.
Penny, excellent. So go on and now add those proper factors to see if it's near perfect. And who has the next good question?
Mr. Kramer,
Always looking for good
honey,
questions.
a question for my fact. I'm doing 72. Mine is
Yes.
72. And I think so. I wrote 4 and 18. Is that the one after? Is that one?
That's perfect. And what's your
Thanks.
now what's your question about that? You were just wondering if half of 36 was 18, Jonah? No,
Yeah.
Jonah? Yeah. So Jonah, watch this. If I'm taking half of 36, Jonah, I take half of 30 and half of 6. Half of 30 is 15, half of 6 is 3, and if you smush them together, you get 18.
Okay.
Okay, man,
Thanks.
keep going. And Sabrina, do you have any good questions for me? Isabella? I love to answer good questions. Tess P, Mark, Olivia, James, Camilla, Hayden, Caroline.
Mr. Kramer,
Yes, sir.
one more question about that. The factor 72. Isn't there a 3? 3
Well,
and
now you go to 8 and 9. 9 is only 3 times 3, so 3 is the next one. 3 goes into 72.
so 24.
And that's 2 carry the 1, or right? So it's 3 goes into 12 4 times. So 24, double and half.
Okay.
And Jonah, stop muting yourself, please. Everybody should be unmuted. Thank you very much. Now, who's going to ask the next great question? Bayram, do you have a question?
I noticed something else about what I did earlier.
Yes, sir.
After I did like the 1 plus 5 thing out of 16, the numbers switched. The first column started halving and the second column started doubling.
Yes, that will happen. Now, who wants to share? Who wants to share the first number they found that was not nearly perfect? Who wants to share the first number they found that was not nearly perfect? So I really want everybody to answer. I have the same people each time, and I'd really like everybody to participate. Okay, Gabby, go.
It was my first number I tried, and I think 60 isn't nearly perfect.
Oh, you tried 60?
Yeah.
Okay, and what did you get for Gabby, what did you get for the sum of the proper factors of 60?
72.
Say again?
72.
Oh, wait a minute. If you got 72, couldn't we subtract the number 12?
Oh, oopsie.
Now, wait a minute. That doesn't mean it is nearly perfect because we have to check your answer. So everybody, let's look.
Wait, Mr. Kramer, when
Yeah.
we're looking for the factors, the whatever, what are they called again? These like
Called
this,
proper factors.
proper factors. If there are two of the same numbers, like 6 times 6 equals 36, if there are two of the same numbers, should I count both of them?
Only one of them. Only one of them. Only one of them.
So
So,
anyways, I actually have something to say.
yeah, but hold on, Baron, because we're working on Gabby's right now, okay? So you have to show her that respect. And
Accident, I made 12 into 11. That's why it didn't work when I tried it.
yeah, but let's make sure we have the proper sum for 60. Can anybody figure out this sum? Because I got 60, 70, 80, and then I got 90, and I got 100, and I think I got 108. Did anybody get 108 for 60?
172.
And if it's 108, what number would I need, everybody, to subtract from 108 to get back to 60? Who thinks they know? On 3, 1, 2, 3, go.
48.
And guess what? Since there is no 48, we can cross out the number 60. It is not nearly perfect. Penny, you want to share?
The first that isn't perfect is 30.
Oh, everybody, round of applause for the first person to find the first abundant number that is not perfect was 30. And
That's
Penny,
what I was gonna say.
oh, great, Baron. Even if you were going to say something, we go like this when we agree. We don't need to say that because it doesn't need to be said. Everybody has their own time, and you get a lot of share time, which is great. And I really want that for you. Mark, what about you?
I think I found the second not perfect number.
Go for it.
I mean,
then.
not near perfect.
Go ahead.
36.
Ooh, what did you get for the sum of the proper factors?
I think I got 48.
Well, 48 minus 12 is definitely 36. So if you got that, now remember, if you remember Barham's really good question about when you have when you have a repeat, you do not count it. So let's check out what we have here. I see 30, 40, 55, everybody. I see a sum of 55. And 55 minus what, everybody? Gives us 36. Who thinks they know? On 3, 1, 2, 3.
19.
19.
And guess what? 19 is not a factor of 36. So 36 is not nearly perfect. But Mark, it's for a different reason. Okay? And let's see. Barham, you have one you want to share?
Yeah, so there was something weird when I was doing 36. Of course, my second time I discovered it. But my first time, I made a bunch of mistakes. I got a bunch of what times what wrong, and then I also excluded a lot of factors. And yet, for some reason, the number I got when I added it up was the same number of when you add up all the normal factors, 45.
You mean
So-
you mean 55?
Oh, I got 45.
Okay, so maybe Mr. Kramer made a mistake. Let's check it out. I did 18 plus 12 is 30. 9 plus 1 makes 40.
10. Oh.
4 plus 6 make 50. And 3 plus 2 make 5 more. 55. So
Oh,
that was
wow.
my method. So Bayram, does that make sense?
Okay, I think I excluded 110 by accident.
No worries. Now, Olivia, can you share yours, even if it was the same one other people did? Olivia, so you had your hand up before. Could you share yours?
I was gonna say the same thing about the 30.
Nice. And what about you, Tess? Tess, you just raised your hand, love. I'm gonna Tess M. Go ahead.
What?
Okay, so Tess, you did not raise your hand. So Jonah, go for it.
I just discovered something. So my factors. So 72 is not a near perfect number.
What was the sum, Jonah?
Oh, so I think the sum when I added all the numbers together
Yes.
was 133.
Wow.
So, and there's no. I think it was like I needed 68. I think.
What do you guys think?
No.
No, I need 61.
Yeah,
And
but
there's
you know
no-
what? Guys, let's check his number out and see if it works. Come on, help me out. 4 and what?
418. 89.
8, 9, 3, 20.
4 and 6 and 12.
Now,
Yep.
let's grab tens, everybody. 36 and 24 make 60. 18 and 12 make 30. That's 90. 9 and 1 make 10. That's 100. 6 and 4 make 10. That's 110. 8 and 2 make 10. That's 123. So, Joni, you got really close. 123, but still we needed 51, which is not a factor. So 72 is definitely not near perfect. And who's going to do the next one? Isabella, what are you working on? Why don't you share something with us that can help us out? Go ahead, Isabella. Isabella, can you hear me? Give me a thumbs up. Can you give us the number you're working on? Isabella, can you speak to us, please? What number are you working on? Isabella, are you going to share with us? Give me a thumbs up if you're going to say your number. Okay. And James, can you share, please? Which number were you working on? And please unmute yourself. Also, David O. and Claire, as well as, yeah, Bayram and Gabby, all unmute yourselves. Okay, go ahead, James. James, are you going to share the number you were working on? Give me a thumbs up if you can hear me.
Mr. Kramer, I have to mute because I have background noise.
Okay, I will see you soon. By the way, at the bottom of the page, Bayram, I also gave you many more abundant numbers to try, and I hope you try them. Claire, what are you working on?
Wait, what are you talking about? I'm not leaving.
Oh, I thought you just said you're leaving. Okay.
I said I have background noise, so I have to mute.
Oh, that's cool. That's cool. Claire, go.
I'm working on the number 100.
Is it near perfect?
Yes. No, sorry, no.
And what was the sum of the proper factors?
It was 50,
Well,
25.
what was the sum? The sum means the total when you added them all up.
The total was it was 27. I mean 177. Sorry.
Was it really 177?
No,
That's-
127.
Right, and remember, we only use one of the tens. So take 10 away from that, and what do you get?
You got 117
And 117 minus 100,
is 17.
we would need a factor of 17 if 100 were near perfect. So 100 is not. David O, can you share yours?
Well, I haven't really finished mine.
And which one are you working on?
48.
Okay, you want to tell me where you, if you hit a wall? Where did you hit a wall?
Well,
Tell me where you hit the wall, please.
I hit the wall at
Come on, David.
8.
David, where did
Yeah.
you, where did you have trouble? At what factor pair?
4.
Okay, so did you have trouble doubling 2 or did you have double taking half of 24?
Taking the wait, what did you say?
I'm just wondering where you were having trouble. If you can maybe explain that, then I could actually help you.
I was getting stuck at 4.
So you mean 4 and 12?
Yeah.
And when you took double 4, did you get 8? What is double 4, David? David, what is double 4?
Is 8.
And what is half of 12?
Half of 12 is 6.
There you go. What is double 8? And what is half of 6?
Double 8 is 16, and then half of 16. Half of 16 is 8.
No, half of 6. You take,
Oh, half of 6 is 10.
well, try again. Try to take half of 6 again. Think of half of 6 is,
Oh, 3.
there you go. And those are the final factor pairs. So everybody, 24 and 6 make 30. 16 and 4 make 20, that's 50. 12 and 8 make 20, that's 70. And 76. Guys, what would we need to subtract from 76 to get 48? On 3. 1, 2, 3.
20.
8.
And it does not, 48 does not have a factor of 28. And therefore you can cross out 48. It is not near perfect. Now, Mark and Gabby, do you want to share?
Yeah.
Go for it.
I was working on 40 and I think that's the next near perfect.
Ooh. Can you tell us what the redundant number was, please?
10.
I like it. Did anybody else get 40? Did anybody else get 40 was near perfect? Caroline, awesome. Caroline, can you tell us another one that you found?
I only did the 31 and the 40.
Okay, cool. We'll try another one now. Jack, I don't see you working because you couldn't be writing based on what you're doing right now. And you need to be writing. Everybody should be doing many, many, many problems. Sabrina, what are you working on? Sabrina, what are you working on, honey? What number? You can choose any number to work on.
I need a new pencil, Mama.
But I think you're muted, honey, so I can't hear you.
A pen.
Yeah, it does.
But I hope you're working on some
I
numbers,
got my
Sabrina.
pencil work today.
Oh, somebody's talking to a parent right now. If you could not do that, that would be awesome. Who's ready to share? Gabby?
The next redone not almost perfect number that I found was 66.
And what are the factor pairs of 66?
Let me see. 1 and 66, then 2 and 33, and then 3 and 22, I think.
I totally agree. And
Then 6, 11.
when you added the proper factors, what did you get?
I got 78.
And 78 take away what is 66?
12.
And let's see if 78 is the right answer. I have 66, 76, 78. I totally agree with you. 66 is not nearly perfect. And Sabrina, are you ready to share yours, honey? And then we can help out each other. Just give me a thumbs up if you can hear me, honey.
I'm working on number 42.
42. Okay. I think 42 is a great choice. And the reason I like it, Sabrina, is because you can take 40 plus 2 and take half of 40 and half of 2. Sabrina, what is half of 40?
20.
And what's half of 2?
1.
And let's smush them together, and what do you get?
21.
So that is half of 42, but we can't take half of 21. So that's a really difficult one. We're gonna have to use goes into 21, Sabrina, which is 3 times 7. So let's start with 7. Do you by any chance know the math fact for 7 times what is 42? Because that'll be our next number. And can somebody please turn that off? That would be awesome. And can anybody help with 7 times what is 42? Go ahead, everybody. Come on, that's a really important math fact.
7.
7 times what is 42? Anybody want to help out? Go ahead. Everybody should know 7 times 6 is 42. And if you don't know it, then let's practice. Now, what about doubling the 7 and taking half of 6? So what is that? Let's double the 7 there, Sabrina.
14
and 3.
And half of 6 is 3. Now, let's add up. And Hayden, did you get a sum for these
No, I
numbers?
just wanted to share one of mine.
Oh, you'll be next, honey. You'll be next. Everybody look at 9 and 21. Does that make 30?
Yes.
Look
Yeah.
at 1, 2, and 7. Does that make another 10? That's 40.
Yeah.
And then 54. So everybody, 54 minus 42 is what number?
Uh,
Come on, everybody
Oh,
should be able to do
eight.
this.
8.
And it is definitely 12. And 12 is
12.
not a factor of 42. Sabrina, would we say that 42 is near perfect?
No.
No, we would not. So you can cross it out. That was a really nice number. I'm really glad that you chose that. Hayden's gonna go and then Jack.
I'm
Go,
working
Hayden.
on 88.
Say again?
88.
88. So 1 and 88. By the way, is it near perfect?
I didn't finish it yet.
Okay, so, well, go all the way then. Go for it.
2 and 44.
Beautiful. Keep going.
4 and 22.
Keep going.
8 and 11.
Amazing. And what, did you get the total yet?
No.
Well, let's just add the right side first. Do you see that that adds up to 77?
Yeah.
And do you see that 8 and 2 make another 10? Hayden, do you see that 8 and 2 make another 10?
Yeah.
And that's 87. And then 87 plus 5 is?
92.
And 92 take away 88 is what number? This is for you only, Hayden. Think what number, how do you get from 88 up to 92? Just add to 88. Come on. How many to get to 90? How many get to 92? Add those twos together and what do you get? Anyone can help out now.
Oh, yeah.
4.
It is 4. And so guess what, guys? We just found that Hayden found a near perfect number. And Hayden, what is the redundant number there? Come on, Hayden, what's the redundant number?
4.
There you go. 4 is the number we subtracted from 92, the sum of the proper factors to get to 88. Nice
Mr.
job.
Kramer?
And
I
Jack,
found another
go
not
for it.
perfect number.
Go ahead, Jack.
80.
Jack, louder, please.
80.
What about 80? Jack, was it near perfect or not?
Well, I haven't done it yet.
Oh, well, you know what? Why don't you give me a number that you've actually done? That's what I want to hear about. Who wants to share a number they've done? Who wants to
Well,
share a number? I'm going to go with,
Mr. Kramer,
yes?
I've hit a wall in 78.
Everybody, let's look at 78. Maybe we'll have time for that one. Guys, what's half of 70 and what's half of 8, everybody?
39. Well,
So
it's
35 plus 4
35
is 39. What goes into 39, Jonah? 3 times what?
3 and 13.
Nice. Now, Jonah, we know that our next factor is 3. This is very much like the one that Sabrina did, where we had these numbers like 3 and 7. So let's look at 78 and let's look at see how many times 3 goes into 78. 3 goes into 7 how many times, everybody? Say it.
0.
2 with the remainder of,
1.
and 3 goes into 18.
6.
6.
And that is our answer. Now, come on, double and half, go.
6.
6.
And 1,
13.
And now, let's add them up. Now, the ones I see first are 1 and 39 is 40. I see, well, what else do I see here? I see 39, that's close to 8, that's 79, and 79 and 80 and 9 is 88. Ooh, I see a 90. 90 minus 78, everybody, on 3. 1, 2, 3, go.
2.
The
Well,
answer is
12.
12. So
Alright.
12 would be the redundant, and we now know that Jonah's number 78 was not near perfect. Now, everybody stop.
Kramer, I have one that's not redundant, and I already did.
Unfortunately, we're out of time. Everybody stop for 1 second, please. I want to show you something. I want everybody to do every number on this list this week. And if you run out of numbers, I went past the first 28 numbers. So if you notice, I did another like 34 abundant numbers that you can try. But don't look at the answer key until you do it. Now, if you hit a wall, I also gave you an answer key just for the factors of all 28 of these numbers. So we can help you get over that wall. Everybody, please say goodbye to your friends
bye.
and say, guys, how does it feel to be nearly perfect? How does it feel to be nearly perfect?
Bye. Bye, Gabby.
Bye, nearly perfect people.
Thank you.
You're welcome.
Okay.